If we want to expand x plus y to the power of n, so in other words, I'm talking about any binomial, a binomial meaning two terms added together, to any exponent n, okay? The first thing I do is I set up the coefficients. And the coefficients are coming from Pascal's triangle. They're the terms in Pascal's triangle, okay? If I have n as my exponent, I don't know why it keeps doing that, n as my exponent, then my first coefficient is going to be n choose 0. And my next one is going to be n choose 1. And then n choose 2. And n choose 3. Etc. And I'm going to end up with n choose n as my last coefficient. So I'm going to start, they're all going to be n, and I'm going to choose 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way till I get to n choose n. Okay? Because that's how Pascal's triangle works. Right? Whatever that number is, we choose 0, we choose 1, we choose 2, we choose 3, all the way to n. Okay? Now I'm going to put in my first terms. My first term is x. And it's going to be x to the power of what? No? N, right? It starts with x to the highest power, and then it's going to go down by 1 every time until the last one is x to the power of? No? 0. Oh, n minus n. Is that what you said? Yeah. So 0. X to the power of 0. And y is going to start at y to the power of 0, and it's going to go up by 1 every time until it gets to be y to the power of n. Okay? That's what we call the binomial theorem. It's using Pascal's triangle and combinations to expand any binomial. And if you look in your textbook on page 740, right, in that little gray box on page 740, that's what they're showing you, is that exact thing. Okay? Now, what if I wanted to make the fifth term in this expansion? The fifth term in this expansion, I would have to have n choose what? N choose 4. So if I want the fifth term, I have to have a 4 here, just like in Pascal's triangle. If I wanted the fifth term in Pascal's triangle, I need to have a 4 here, okay? And I'm going to have x to the power of what? What's x going to be to the power of? All right, how about this one? What's y going to be to the power of? Not 5, but close. Y is going to be to the power of 4, and x is going to be to the power of n minus 4, right? Just like all of these terms, y is to the same power as the r value, and x is n minus that r value. Okay, x is n minus the r value, and y is to the power of the r value. Okay? Now, your textbook does it one way and your formula sheet does it another way, so I'm going to do the same as the formula sheet. I think it's a little bit better. It says that let's find the k plus 1th term. Okay, so in other words, if we're trying to find the fifth term, then k is what? What value of k would give me the fifth term? 4, right? Because 4 plus 1 is 5, and that's the fifth term. Okay, and we're using that so that over here, I can do n choose k, because k has to be 1 less than whatever the term number I'm dealing with. So if k plus 1, then 1 less than that is k. And we're going to have x to the power of n minus k, y to the power of k. Okay, and that's what it says on your formula sheet. In your textbook, they don't use k plus 1th term, they use the kth term, and then these guys have to be subtract 1, and so it's just a bit more of a mess over here. Okay? But the whole idea is whatever term we're talking about, then the r value is 1 less than that, and this is how we set up the exponents. Okay? Questions about that? Okay, so you don't have to have it memorized because it's on your formula sheet. Actually, what they have on your formula sheet is, let's get rid of this. It says t sub k plus 1. So it means the term that is the k plus 1th term. And then they have n choose k, x to the power of n minus k, y to the power of k. All right, you'll see it on your formula sheet there if you look for it. So you don't have to have it memorized because it's on your formula sheet, but you do have to understand what it's telling you. And it's telling you that any term in the binomial expansion can be generated here. How do we get the first term? What is k for the first term? What's k for the first term? 0, because 0 plus 1 is the first term. So we would have n choose 0. We'd have x to the power of n, y to the power of 0. If we wanted the second term, then k would be equal to 1. And we do it again. What if we wanted the last term? What would k be equal to? For the last term. Pardon me? You would think that, but you would be close, not quite. For the very last term, we want it to be y to the power of n, so k would have to be n. The last term would be n plus 1. What that means is that when we're expanding it to the power of 5, like we did here, how many terms are in that expansion? To the power of 5, how many terms in the expansion? Nope. Count them. 6 terms in the expansion. Okay, so there's one more term than there is the exponent that we have. Okay? Okay, so I'm going to do 2 examples today to show you how we will use this going forward. Okay? And what's nice about it is that you can expand binomials that you wouldn't want to do by hand, that you wouldn't want to do by writing the 3 terms out and doing it, or the 5 terms or whatever. Okay? I'm going to change this to be a power of 4, just because it's a little harder, but it's not too hard. Okay? So we're going to expand 4a plus 2b to the power of 4 using the binomial theorem and see how that looks. Okay? How many terms am I going to have in this expansion? It's a power of 4, so I'm going to have 5 terms, okay? And that's just something to think about because you should be thinking about those patterns. But also it tells me I need to have 5 terms, so I need to leave myself a little bit of room across here, okay? So when I do it, I usually do it in parts. I don't do each term, I do each part of each term. So the first thing I do is the coefficients. I do the chooses. And what am I going to have for my chooses? What's the number I'm going to write first? What's n? 4. So I'm going to have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 4, no, 4 choose 3, and then 4 choose 4. And I didn't leave myself quite enough room. But look, I can make more. Okay? Now, I put in the first term. And I need brackets now because I've got a 4 with it. So it's 4a to the power of, what's my first power? 4, which is n, right. And then I'm going to have 4a to the power of 3, and 4a to the power of 2, and 4a to the power of 1, and 4a to the power of, what's the last one? 0. Okay? Does that make sense? Now I'm going to put in my second term, and my second and final term, 2b. The very first one is going to be to the power of 0. And then it's going to be 2b to the power of 1, 2b to the power of 2, 2b to the power of 3, and 2b to the power of 4. And all of these are pluses. Okay? Everybody follow that? So just using the patterns, the binomial expansion coefficients come from Pascal's triangle, which we can generate with combinations, and then we have first term, second term, and the exponents go up, go start at n and go down for the first term, and start at 0 and go up for the second term. Okay, now we're going to just pretty it up. Okay, and I'll do it in 2 steps. What is 4 choose 1? 1. And what's anything to the power of 0? 1. So what I have here is 4a to the power of 4. What's 4 to the power of 4? No. What's 4 to the power of 4? Anybody with a calculator? 256. Okay, so I have 256a to the power of 4. That's my first term. Okay? 4 choose 1. What's 4 choose 1? 4. And here I have 4a cubed, so that's 64a cubed. And I have 2b to the power of 1, that's 2b. What is 4 choose 2? 6. Okay, and 4a squared is 16a squared, and 2b squared is 4b squared. 4 choose 3 is another 6, isn't it? It's not 4, no. Is it? 4? No, it's 6, 4, 1. That's 6. 4 choose 3 is 4? 4. Oh, I did. Oh, sorry, I'm missing. Yeah. Sorry. Thank you, Henrik. You're right. And thank you, Emily. Okay, 4 times 4a. And then 2b cubed is 8b cubed. Okay, this is now, it's right. And 4 choose 4 is 1. 4a to the power of 0 is 1. So I have 2b. Whoops, this 4 should be outside the bracket. My mistake. So that is 16b to the power of 4. Okay.
Why is it not 256 in the first one? Why is it 16?
Because it's 2 to the power of 4 is 16.
Oh, gosh.
Yeah, the other one was 4 to the power of 4. That's why it was 256. Okay, so now I've got one last step just to finish up these in-between ones. So you're going to have to help me with your calculators for some of them. I need 4 times 64 times 2. So what's 4 times 64 times 2? Sorry, 512? And now I need 6 times 16 times 4. 3, sorry, 84. And now the last one I need is 4 times 4 times 8. So 16 times 8. 128. Okay. And so that's how we will expand a binomial, using those patterns. Okay? Notice down here that the coefficients are not Pascal's triangle anymore. Right? Why? Why are they not Pascal's triangle anymore? How come I'm not 1, 4, 6, 6, 4, 1? Henrik? Right, the 4 and the 2 here messed that up for me, right? So I'm not going to have necessarily Pascal's triangle down here anymore. I had Pascal's triangle here with the 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. That's what's creating that 1, right? The 1, 4, 6, 4, 1. Here's my 4, my 6, my 4. These ones had 1s in front of them that I didn't write down. Okay? The powers in this case do follow the pattern. The a to the power of 4, a to the power of 3, a to the power of 2, a to the power of 1, a to the power of 0, b to the power of 0, b to the power of 1, b to the power of 2, b to the power of 3, b to the power of 4. And that's because these didn't have exponents on them. But you can see binomials where you would have an exponent in here. You could also see coefficients that were fractional. Okay? You could see negatives in here. All of those things make it a little more difficult because we tend to make more mistakes with negatives. We tend to make more mistakes with fractions. Having the exponents just adds that other layer of complexity. But the way we set it up is exactly the same. Just like that. And then it would be the simplifying where you would make those mistakes, possibly. If you know, could make mistakes, let's just say. Because the more complex it is, the more likely the mistakes are going to happen for everyone. Okay? But that's how we set it up. So questions about that? All right, the only other kind of question that I could ask you is one like this, where I give you a binomial expansion and I say, tell me the 9th term in the expansion. So when I say that, I'm not asking you to do the whole thing and expand it out like we did here. You certainly can do that, but you don't need to. If I want to know the 9th term in the expansion, what does k equal?
8.
K equals 8. So I need to set up my coefficient, and it's going to be what? Choose what? 10, choose 8, right? Because n is the exponent, so that's what goes in front. And I'm choosing 8 because it's k is equal to 8 for the 9th term. Okay, that's the Pascal's triangle situation that I'm asking you. I'm saying it's the 9th term, so it's choose 8, but n is 10. Okay? Now I take x squared and I take negative 2. Those are the two terms I'm dealing with. What are the exponents on those two terms? What's the exponent on the x squared and what's the exponent on the negative 2? Negative 2 is 0, and then x squared would have to be 10. Does that make sense? So that only occurs in what term? The first term. But I'm asking you for the 9th term. So what's going to be? So talk about it with your group. What's going to be on the x squared and what's going to be on the minus 2? Which one gets the 8? The negative 2, right, Henrik? And so the x squared gets the 2. Those two have to add to 10. And that one is the same as that one. Okay, if we roll it up here for a minute, notice this is the same as this. This is the same as this. This is the same as this. So the second one, exponent on the second one matches up with r. The first one gets the difference between the two. Okay? So now we're going to make this look pretty. What is 10 choose 8? You could put it in your calculator or you could do it in your head. We did this one in our head yesterday, I think. It's 45. X squared squared is x to the power of 4. Minus 2 to the power of 8. Is it going to be positive or negative? Positive, because it's an even exponent. And what's 2 to the power of 8? 2 to the power of 8 is 64? 256, yeah. And so now I need to know what's 45 times 256. Anybody with a calculator?
11, 5, 20.
So that is the 9th term in the expansion of that. Okay? You need to practice some of these. And I'm recommending these questions here.